Okay, boys and girls, we are going to do strategy number 2 today. So strategy number 2 is like strategy number 1 where we want to make the denominators the same. So I'm going to give you this problem. We're going to do 3/5 and we're going to compare it to 2/6. In strategy number 1, I had to decide if I can multiply one of the denominators to get to the other denominator. So I want you to ask yourself, can you do 5 times anything to get to 6? The answer is no. There's nothing to multiply it by, so we can't use strategy number 1. So we're going to use strategy number 2. And this is where you multiply the denominators by each other, meaning that I would multiply 6 times 5 on this side, which if I multiplied 5 by 6, or 6, if I multiplied 5 times 6, I'd also have to do 3 times 6, because whatever I do to my denominator, I do to my numerator. So I need to create these into the same, and I do it by multiplying by each other. And what I mean by that is I take 3/5 and I take 2/6. And I'm going to multiply 3/5 by 6. And you'll see why in a second. And I'm going to multiply 2/6 by 5. So when I do this, 3 times 6, 18, 5 times 6, 30, 2 times 5, 10, 6 times 5 is 30. I now have 2 equivalent fractions for the originals that both have the same denominators. So now I can compare those 2 fractions. So I have 18/30ths and I'm comparing it with 10/30ths. This is just another way you can make your denominators the same. So as I look at these, I can see 18 is bigger than 10. So in the end, 3/5 was bigger than 2/6. So unlike strategy number 1, I'm not multiplying one denominator to get to the other. I'm multiplying the denominators by each other to create a product that is the same. So there they be equal to each other. Okay, so let's try another one. So let's do 3/7, and we're going to compare it with 4/5. So I asked myself, is there anything I can multiply by 5 to get to 7? Or the opposite, is there anything I can multiply by 7 to get to 5? Is there? Everyone should be screaming out, no, there's not. So we can't do strategy 1. Strategy number 1 is out. We can't do it. So I have to do strategy number 2, where I multiply this denominator, 7. I'm going to multiply 4/5 by 7, or by 3/7 by 5. So what that means and what that looks like is I take 3/7 and 4/5. I'm going to multiply 3/7 by this denominator. So that means I multiply the top and the bottom by 5. And then I multiply the 4/5 by this denominator, 7. When I do this, because I'm multiplying them, 5 times 7 and 7 times 5, they're the same answer, right? So that means I get the same denominator each time. So I have 7 times 5 equals 35. 5 times 7 equals 35. So now I just get my new numerator. 3 times 5, 15. 4 times 7, 28. And I can now compare these equivalent fractions I just created with each other. So I'm taking 15/35 and I'm comparing it with 28/35. and I look at my numerators and decide, which one's bigger? 28 is. So in the end, 4/5 was bigger than 3/7. With this one, I'm just creating the same denominator by multiplying the denominators by themselves. So I'm multiplying 7 by 5 and 5 by 7. And because of that, I get the same denominators. So I want you to try this next one with me. Let's do 3/8, and let's compare it with 6/9. Okay, so I'm going to look and see if I can do strategy number 1. Can I times anything by 8 to get to 9? Or can I times anything by 9 to get to 8? The answer is no. So I have to take my fractions 3/8 and 6/9. And I need to multiply them by the other denominator. So 8 is the denominator here. So would I multiply this by 8? No, I need to come down and look at this denominator. I'm going to multiply the top and the bottom by the 9. For 6/9, I'm going to multiply it by the other denominator of 8. So I multiply the top and the bottom by 8. By doing this, I have 8 times 9 and 9 times 8. They're reciprocal, meaning that they have the same answer. So I can find that this new equivalent fraction to 3/8 would be 27/72. And my fraction for 6/9 that's equivalent would be the same as 48/72. I created the same denominator, so now I can easily compare them. So I look, oh, my bad. Let's see, oh, that's the eraser. There we go. There we go. That's right. Now I can look and see, oh, that one's bigger. Okay, let's try this one. I have 1/3 and 2/6. Let's see if we can do strategy number 1. Is there anything I can multiply by 3 to get to 6? You should all be screaming out, yes, Mrs. Anderson, 2. So do I have to do strategy number 2 or can I use strategy number 1? I can use strategy number 1. So I'm going to take 1/3 and I'm going to multiply the top and the bottom by 2 because strategy number 1 worked, which gives me the equivalent fraction of 2/6. This is the same as that 1/3. So now I can compare. I have 2/6 and 2/6. So I can see they were equal to each other. So it's easier to do strategy number 1 when you can because you only have to make one equivalent fraction. Strategy number 2, you have to make 2 equivalent fractions. So it's the best when we can just do it once. So if you see that strategy number 1 works, don't take the time to make an equivalent fraction of strategy number 2. Only do strategy number 2 if strategy number 1 does not work. Okay, we're going to try some where you do it on your own. So you're going to pause the video and you are going to try it on your own and then you're going to watch it and see how you did. So let's do 5/8 and let's do 4/7. Okay, I want you to solve this problem. Press pause and when you're ready, turn it back on and see how you did. So my first step is to always check my denominators. And I ask myself, is there anything I can multiply by 7 to to get to 8 or vice versa? And the answer is no. So that means I can't do strategy 1. I'm going to have to create 2 equivalent fractions. So I rewrite my fractions down here. And I'm going to multiply my 5/8 by this 7. Doing this gives me a multiplication equation that will let me get the same denominator. Now I'm going to divide, times 4/7 by 8. See how I have 8/7 and 7/8? They will both give me the same answer. So for the numerator, I got 35 because 5 times 7 equals 35. For the denominator, I have 8 times 7, which would give me 56. Now I move on to this one. I have 4 times 8 is 32. 7 times 8 is 56, and I know that because 8 times 7 was 56 up there. So now that I have my new equivalent fractions, remember this fraction is the same as 5/8. This fraction is the same as 4/7. I can now use those to compare. So I'm going to do 35, 56, and I'm going to compare it to 32, 56. And I look at my numerators. This numerator is bigger, so that fraction must be bigger. So in the end, 5/8 was bigger. Okay, let's do one more where you practice it on your own and check your work with mine after. Let's do 5. Oh, we just did 5. Let's do 6/8. And let's do 2/4. So I want you guys to pause the video, work through the problem. Then when you're done, check your work through mine. If you need help, remember I'm on Google Hangouts. Okay? So pause it. When you're ready, turn it back on. Okay, so my first step is to check. And I ask myself, can I do 8 times anything to get to 4? Or 4 times something to get to 8? Well, I can't do that one, but I could do this one. 4 times 2 gives me 8. So do I even have to do strategy number 2? The answer is no. I can go straight to strategy number 1 where I take 2/4 and I create an equivalent fraction that gives me the same denominator of 8. So since it was 4 times 2, I have to do times 2 on the top too. So 2 times 2 is 4. 4 times 2 is 8. So I now have my equivalent fraction that's the same as this 2/4. So I can do 6/8 compared to 4/8. And I can see 6/8 was bigger. Now let's say I didn't notice that I had the same, or that I could do strategy number 1. And I just went ahead with strategy number 2. It would still work. If I took 6/8 and 2/4 and I multiplied the 8 by the 4 and I multiplied the 4 by the 8 because 8 times 4 and 4 times 8 gives me the same answer. But if I do it to the bottom, I have to do it to the top. So I would get 24 30-seconds. And for this one, I'd get 16 30-seconds. Now I have my 2 equivalent fractions that equal the same as these fractions up here. So I can compare these 2 new fractions now and decide which one's bigger. And as I look, I can see 24 30-seconds is bigger because 24 is bigger than 16. It's the same exact thing as what we got when we did strategy number 1. So if you don't notice and you do strategy number 2 for these, it will still give you the same answer. I hope this helps. If you need me, I'm on Google Hangouts. We can solve these step by step together, okay? Thanks, guys. Bye.